Now let us solve the first question of exercise number 8.1. The angles of a quadrilateral are in the ratio 3 is to 5 is to 9 is to 13. Find all the angles of the quadrilateral. Now let the angles of quadrilateral be 3x, 5x, 9x and 13x. And as we know that sum of all the angles of a quadrilateral is equals to 360 degree. Therefore, 3x plus 5x plus 9x plus 13x is equals to 360. And the reason is the sum of all the angles of a quadrilateral is 360 degree. Now 3 plus 5 8, 8 plus 9 17, 17 plus 13 is 30. So 30x is equals to 360 degree. So x is equals to 360 upon 30. So that will be equals to 12 degree. So the value of x is 12 degree. So now we'll take the first angle, that is equals to 3x. That means 3 into 12, that is equals to 36 degree. Then we have second angle, that is equals to 5x, that is 5 into 12, that is 60 degree. Then we have third angle, that is equals to 9x. So 9 into 12, that is equals to 108 degree. And the fourth angle, that is equals to 13x. So that is 13 into 12, that is equals to 156 degree. So all the angles are 36, 60, 108 and 156 degree. Now let us solve the second question of exercise number 8.2. If the diagonals of a parallelogram are equal, then show that it is a rectangle. Now in the question it is given that ABCD is a parallelogram and this we have marked as number 1. And what we have to prove, and also it is given that diagonals are equal, AC and BD are equal. This is given in the question. And what we have to prove in the question is that ABCD is a rectangle. So how we can prove it rectangle? What we can do is, a parallelogram is already given in this question. If we can prove any one of the angle equals to 90 degree, then a parallelogram with one of its angle 90 degree is a rectangle. So we have to prove one of the angle of this parallelogram to be 90 degree. So how we do that? Just see, we will take the two triangle, in triangle ABC and triangle DCB. We are going to prove these two triangles congruent. Now in this it is given that AB is equals to BC. It is opposite sides of parallelogram. Opposite side of parallelogram are equal. This is given, this two sides are equal. Now BC, if you see, BC and CB both are common. So in this triangle ABC, BC is there, and the triangle DCB, CB is there. So these are equal. So BC equals to CB, they are common. Now one more thing is given in the question, that the diagonals are equal. In the question it is written if the diagonals of parallelogram are equal. That means AC and DB are equal. AC is equals to DB. It is given in the question. So now the two triangles are congruent. Triangle ABC is congruent to triangle DCB by the rule known as SSS congruence rule. This is the Okay, so now these two triangles are congruent by SSL. This angle and this angle, they will be equal because the corresponding parts of congruent triangles are equal. So we can write the angle ABC is equals to angle DCB, that is equals to they are equal because of corresponding parts of congruent triangles are equal. Now if you see this AB and DC are parallel, AB is parallel to DC, so this angle and this angle, they are forming co-interior angle, and the sum of co-interior angle is 180 degree. So angle ABC plus angle DCB is equals to 180 degree. So angle ABC and DCB both are equal, so we can write angle ABC plus angle ABC is equals to 180. So twice of angle ABC is equals to 180 degree. So angle ABC will be equals to 180 upon 2, and that is equals to 90 degree. This is marked as number 2. Now in the first, it is given that ABC is a parallelogram, and in second equation we have proved that one of the angle is 180 degree. So from first and second, from equation first and equation second, we can say that ABCD is a rectangle, and the reason is that a parallelogram whose one of its angle is 90 degree is a rectangle. Now let us solve the question number 4 of exercise number 8.1. Show that the diagonals of a square are equal and bisect each other at right angle. So this is the figure I have drawn. This is a square, and AC and DB are the diagonals. So we have to prove that the diagonals are equal, that means AC and DB are equal, and we have to prove the diagonal bisect each other, that means AO and CO are equal and DO and DO are equal, and also they are bisecting each other at 90 degree, that means we have to prove that angle 5 equals to angle 6 equals to 90 degree. So let us first prove the first part, that the diagonals of square are equal. So let us take the triangle. So we will take the in triangle ABC and triangle DCB, and let us prove these two triangles congruent. AB is equals to DC. We know that opposite sides of square are equal. Opposite side of square are equal. Then it is given in the question that this angle and this angle will be equals to 90 degree, as we know that all the angles of a square are equals to 90 degree. So angle ABC is equals to angle DCB, that is equals to each 90 degree. And third is, this is BC and CB are common. In the triangle ABC, BC, and in the triangle DCB, CB, they are common. So these two triangles are congruent by SAS rule. So triangle ABC is congruent to triangle DCB by the rule known as SAS. It is side, angle, side. Again side, angle, side. So they are congruent by SAS congruence rule. Now since these two triangles are congruent, then the corresponding parts will be equal. This AC of the triangle ABC and DB of triangle DBC both are equal. So we can write AC is equals to DB, and the reason is corresponding parts of congruent triangles are equal. Now we will take these two triangles, this triangle and this triangle, that is in triangle AOD and triangle COB, and let us prove these two triangles congruent. So as you can see that these two sides AD and BC are equal, parallel. So angle 1 and angle 2, they will be alternate interior angles. So angle 1 is equals to angle 2, alternate interior angle, alternate interior angle. and AD, this AD and this CB both are equal, as we know that opposite sides of square are equal. Opposite side of square are equal. And the third thing that we'll be using is angle 3 and angle 4. Again they are alternate interior angle. So angle 3 is equals to angle 4, alternate interior angle. Alternate interior angle. So these two triangles are congruent. Again, angle AOD, a triangle AOD is congruent to triangle COB by the rule that is angle side angle. You can see here angle side angle. So ASA congruence rule. Now by CDCT, that means the corresponding parts of congruent triangle, that is AO is equals to CO and BO is equals to DO, that is due to CPCT, that is corresponding parts of congruent triangle. Now let us take this. We have proved that the diagonal bisect each other because AO and CO are equal, DO and BO are equal. We have proved here. So that means the corresponding parts of congruent triangles are equal, that we can say that diagonal bisect each other. But one more thing we have to prove, that they bisect each other at right angle. That means we have to prove that angle 5 equals to 90 degree. For that we will take the triangle AOB and triangle AOD. Now again we are going to prove it congruent. So how we will prove that? AB is equals to AD, these two sides, because the reason is the adjacent side, or you can say all the sides of the square are equal. Then AO equals to AO, common. Then we have BO is equals to DO, that we have proved earlier here. You can see proved earlier. Okay. So BO is equals to DO, we have proved it here. So now these two triangles, again, that is the triangle AOB is congruent to triangle AOD, and the rule is, you can see here all the three sides are equal to the three sides of the other triangle. So the rule is SSS congruence rule, that you can write here. Now since these two triangles are congruent, angle 5 will be equals to angle 6, and angle 5 plus angle 6 is equals to 180 degree, as we know that they are forming linear pair. Since angle 5 and angle 6 are equal, now why this angle 5 and angle 6 are equal? Because these are the corresponding parts of congruent triangle. So angle 5 and angle 6 is equals to 180 degree, linear pair. This is forming linear pair. So angle 5 plus angle 6 can be written as angle 5 is equals to 180. So twice of angle 5 is equals to 180. So angle 5 is equals to 180 upon 2, and that is equals to 90 degrees. So we got angle 5 is equals to, and this is 90 degree. So now here AO is equals to CO, BO and equals to DO, that means that they are bisected, and since angle F is equals to 90 degree, that means the diagonals are bisecting each other at 90 degree.